explain why. This presentation was done together with my collaborator, who is present here, Yura Yerin, and so I will proceed with. Sorry, why it does not? It was okay. Yes. So I will start my overview from the history of Ukrainian science, not like Italian, of course. I cannot start from the times of Galileo or Copernicus, but I will start from inception of the natural sciences and emergence of universities in Ukraine. Then I will speak about very short period in the history of Ukraine in 1918, when Ukraine 1 year was independent country. Then I will relate the fall of Ukrainian independence and the immigration of Ukrainian intellectuals during the turbulent first decades of the Soviet states. So I will relate such names like Gamov, like Timoshenko, with Ukraine. Then I will devote the central part of my talk. I will speak about Kharkov Center. But if I speak about Kharkov Center, of course, I cannot ignore the Kiev Center. So there are other centers, but and there are good results in thermoelectricity in Chernivtsi, etc. Nevertheless, I will stop here, and then I will pass to my modest experience of collaboration with Ukrainian scientists, with Institute of Bogolyubov, with Institute of Semiconductors in the framework of European projects during the last decade. And it was very fruitful, and it was a period of integration of Ukrainian science in European science. And finally, of course, I cannot skip the current state with science in Ukraine. So I want to start with disclaimer, namely, what is happening? Sorry, no, I don't understand. No. Okay, yeah. Why not? So first of all, I want to make some disclaimer and to define what I will call, what will I attribute to Ukrainian science. Because this is discutable. For instance, Enrico Fermi was American scientist or Italian scientist? The question. Well, nevertheless, Italy can be proud by Enrico Fermi. Absolutely. So I want to say that I will attribute to physics in Ukraine the outstanding scientific achievements by scholars which were born and formed in Ukraine. This is one point. The second point, I will call as a Ukrainian outstanding scientific achievements of scientists affiliated with the Ukrainian academic and university institutions during the period of work on the discovery. Why? Because the word alma mater in Latin means the mater who feed you. So, speaking in more practical, affiliation means that you are paid from this institution. So, it is natural that if you are paid by this institution, so achievement should be attributed to this institution. So, and the third disclaimer is that I will speak only with one exclusion about the condensed matter achievements. So I don't pretend nuclear physics, etc., etc. So only one I will make exclusion, and you will understand why. Very good. So now, what is happening? I don't understand. Okay. So if you will go to Bologna University, we are in Italy, and Bologna University was the first in Europe. And with surprise, when I started to prepare my talk, of course, did some research, and I found that the rector of Bologna University in 1481 was do not want to say Ukrainian, but the person who was born in Drogobich, which is now Ukraine. Those times it was Poland, and Yuri Drogobich, or Yuri Katermak, or Giorgio de Leopoli, who was born in 1450, in Ukraine, was a Ukrainian philosopher, astronomer, writer, medical doctor, rector of University of Bologna, professor of Krakow University. So this is curious fact, and now I will pass to more concrete. So where first universities, first academical institutions were founded in Ukraine. It was the Ostrog Academy, which was founded close to Rivne, so it is west of Ukraine, and it was founded in 1576. More or less 50 years later, the Kiev-Mohyla Academy, which still exists, was founded in Kiev. In 1661, the university was founded in Lviv, the principal city of Polish-ruled Western Ukraine. And here, this is not only historical fact, but now appears the names which all of us know with you. The names like Stefan Banach. You remember Banach's thesis. He, certainly we learned it in functional analysis. He was a founder of functional analysis. He studied in Lviv University. Then Marian Smoluchowski, close to Vienna, but his career he did as a professor of Lviv University. Václav Sierpiński, who was a mathematician known for contributions to set theory, number theory, and theory of functions in topology. And Stanislav Lem, who was not scientist, but he was philosopher, writer, and certainly a lot of us in childhood and maybe in years read his wonderful, we saw Solaris and other things. So these people make a globe for Lviv University. Then, Kharkiv. In Kharkiv, university was established in 1805. And with the recent story of Kharkiv, we'll speak a little bit later. But again, it is impossible to avoid the names like Ilya Mechnikov, who got Nobel Prize in Medicine in 1908. He was student of Kharkiv University. Lev Landau was professor of Kharkiv University, and not too long. I will tell later, because he was fired. Because Lev Landau, in 1935, taught quantum mechanics, just born quantum mechanics, and Landau took part in the creation of quantum mechanics. He was lucky because he was very young. He was born in 1908. So in 1928, in 1926, when Ernst Schrödinger wrote his equation, he had only 18 years. But he was the genius. He was very early. He became physicist, real physicist, and he had succeeded. We know Landau quantization. So in 1930, he wrote the fundamental seminal paper about the behavior of electron in magnetic field, which gives work for all of us during years. Okay, so why he was fired? Because quantum mechanics contradicted the Marxist deterministic understanding of the world. And he was fired because of this. Consequences I will tell you later. Okay, now I will pass to establishment of Kiev University. I was born 5 minutes from this building, and it was established in 1834. And as famous persons, I was looking for, not too much, but the historical persons, but Mikhail Avenarius came as a professor of this university, and he contributed in thermoelectricity. I was looking for his formula because it exists formula of Avenarius. I know Mott formula. I know the Kelvin formula for thermoelectricity, but I did not find Avenarius formula. I found reference on it in 1896 in the of American Academy of Arts, but I didn't succeed to download this article, so I cannot reproduce you form. I would like, but I do not have it. Okay, but the person who definitely all of us know, it was the Nikolai Bogolyubov, the king who, in age of, it seems, 10 years or 12 years, actually he was a self-made man, absolutely, but his PhD thesis he defended in Kiev University. Okay, so more or less I finished with this old story, and now I want to pass to establishment of the Ukrainian National Academy of Science. From the Italian point of view, where the Lincei Academy or Istituto Lombardo was established by Napoleon in 1797, so Ukrainian Academy, yeah, it has a little bit more than 100 years. But I want to stress that it was the 1918 was very hard year, because 1 year ago the Emperor of Russia resigned, and it was a turmoil, political turmoil, and Ukraine separated from Russian Empire, and this independent state, very amorphous, very fragile, existed only 1 year. But interesting that the ruler of this, the Hetman Pavlos Karapatsky, he took time and found some to create Ukrainian Academy of National Academy of Science. Then this state was eliminated by future Soviet Union, and this situation was very bad. It was civil war, and a lot of intellectuals immigrated. Someone understood it from the beginning, like Igor Sikorsky, who was born in Kiev in 1889, immigrated to the United States already in 1919. Now, you know, all helicopters which we see were created by Sikorsky, and some airplanes. Or the Stefan Timoshenko, who was the founder of the science of strength of materials, and he became professor of Stanford University. The theoretical physicist George Varlamov was born in Odessa, and he tried to escape from Soviet Union. Once in the board through the sea. But finally, he did it in 1934, and we relate the explanation of alpha radioactivity with his name and many other. He was a prominent popularizer of science. We know his books. And so I mentioned you only 3 persons. And now I think it is time to pass to my central part of my talk. I will speak about Kharkov Research Center. It was established in 1928. How it happened? So in 20th was proclaimed by Lenin new events in politics. And so the rigid ideas of revolution were slightly removed, and to have bread in shops, etc., it was necessary a little bit to give freedom of. And then this period, when Stalin became the first general secretary of Communist Party, he decided to industrialize Russia, to transform agricultural country in industrial country. And we understand whether that industry means science. So the rare institutions of Russian Empire in St. Petersburg, Leningrad, so Yoffe, had some political support. At those times, politicians listened, scientists. And they decided to create, to decentralize science and to create several centers in province. One of them was Kharkiv. And it is necessary to understand that this period was very particular because Landau worked with Bohr. Kapitsa worked with Rutherford. Ideas of communism were popular in West. So Kharkov became the international center. And if I will tell you that there visit such people as Bohr, so indeed this was some period of spring. You can see what told the Nobel laureate Fritz Haber. If you succeed in realizing what you have planned, you will have the best physics institute in Europe. He visited it, being a Nobel Prize, and he appreciated the dreams and realization. So here I show you, so I start with Ukrainian Institute of Physics and Technology, which was established in 1928. How it will be established, I will show you now. But speaking about the nowadays, I cannot ignore, of course, the Institute for Low Temperature Physics and Engineering, which we know a lot of colleagues from there. So I mentioned it here out of historical line. So 1932. This is the only exclusion from condensed matter, which I will allow me, because this was important. Leipunsky, Sinelnikov, Walter, and Latyshev built in Ukrainian Physical Technical Institute the high voltage van der Graaf generator and split off the lithium nuclei by protons, by flow of protons. It was 5 months after the John Cockcroft and Ernst Walton did the same in Cambridge. So this idea, to bombard lithium nucleus by protons was proposed by Gamov. And the era of acceleration-based experimental physics was born. Cockcroft and Walton were awarded the Nobel Prize. But it is not bad result that in institute which just is created to get almost Nobel Prizes. So it is why I mentioned this as a first achievement of the institute. Then the important figure in Kharkiv Institute was Lev Shubnikov. All of us knows effect Shubnikov de gas. Please pay attention that Shubnikov de gas, not in alphabetic order and not in order of importance, because van der Gas was a director of Kamerlingh-Onnes laboratory, and he decided to put Shubnikov. So why? Because after Kamerlingh-Onnes, when he was retired in 1924, the laboratory was split for two. One belonged to the van der Gas, another to Kayes. Kayes concentrated on studies with helium, and he had succeeded in 2 years to do what Kamerlingh-Onnes did not succeed. He solidified helium, because Kamerlingh-Onnes was trying to decrease temperature, and Kayes applied pressure. So, and we understand with you that helium is a quantum crystal. So the zero oscillations destroy you the order, but it is enough to press, and you get the solid phase. Okay, while van der Gas, he concentrated on studies 1926. In 1930 was discovered the Shubnikov de gas oscillations. This was the first quantum effect. And they studied magnetoresistance of the bismuth crystals. And Kapitsa studied 2 years ago, and he did not find any oscillations. Why? Because the gas perfectly understood that he needs perfect crystals. And the merit of Shubnikov was young student of Abraimov. He just finished his master degree. And he was metallurgist. In first, he was metallurgist. And he, with Abraimov, they developed their original technique of growing crystals, the perfect crystals. And people concentrated on bismuth those times. Kapitsa started the same magnetic resistance, and he found linear magnetism, but he did not find oscillations. We understood with you that to see quantum oscillations, it is necessary to have low temperatures and clean crystals. So this was the merit of Shubnikov, which was very appreciated. But besides being very good metallurgist, he was found to be very talented experimentalist because he learned how to work with low temperatures and how to measure transport effects. I always believed that the gas Van Alphen effect was discovered before. No, actually, the gas Van Alphen was discovered half a year after Shubnikov the gas on the crystals of Shubnikov. So he was very important figure in Leiden laboratory. In 1930, the times started to change. So he got the order to return to Soviet Union. So he left Leiden laboratory and returned to Soviet Union. He got this order to St. Petersburg, where he was formed as a student, but he did not find funds and practical position. Those time, Joffe, who was director of future Joffe Institute, which we know, he participated in creation of Kharkov Center. And he sent Shubnikov there. He sent Shubnikov with different promises that the equipment for cryogenic laboratory will be bought, etc. So he came with these promises. We know how things are going. So 1 year he just dreamed, but then indeed, because his boss, Abraimov, hoped that Kapitsa will accept position of the director, but Kapitsa promised and did not accept the position of the director of cryogenic laboratory. So Shubnikov, in very short time, created, I do not explain what is the physics of Shubnikov the gas oscillation. I think that it is well, but up to my mind, I was surprised that this was actually first quantum effect measured. Then Landau wrote his famous paper, but he spoke about diamagnetism of to finish with this, of electron system. And he just mentioned that in principle could be some oscillations, but they are not observable. Explanation of Shubnikov the gas effect was given by Landau when he was in prison. Actually, Schoenberg came to Kapitsa Institute in 1937, and he discussed with Landau, he was experimentalist, and he measured Shubnikov the gas effect, and he published in 1938 when Landau was in prison, and as an appendix, he added explanation of Landau, making reference that this derivation belongs to Landau. So it was in such strange way published his result. Okay, so now I will proceed to other achievements of Shubnikov, very important. You remember that Walter Meissner with the Robert Oxenfeld, they observed the non-trivial, because until 1933 people believed the superconductor is an ideal conductor. What means ideal conductor? Ideal conductor means that electric field in it must be zero, because J equals sigma E. Sigma is infinite, so E must be zero if you have finite current. But ideal conductor should not feel TC. So ideal conductor should be if E equals zero, so magnetic flux should not change from the second equation of Maxwell. So what they discovered that actually superconductor is different from ideal conductor. So they recognized 20 years after discovery of Kamerlingh onus, because passing through TC, so if you might experiment, so you have superconductor in magnetic field, you decrease field, so there is a flux. But when you pass across TC, so this flux is expelled. And today we can explain with you, we understand the second order phase transition, we can write free energy, etc. But those times it was unknown. So what did, how Meissner and Oxenfeld measured their effect? They measured local value of magnetic field close to superconductor, around its surface. But Meissner liquefied helium in 1925 in Berlin. And he had huge experience of work with superconductor alloys. He discovered superconductivity in niobium. So he was an experienced person. So he arrived to magnetic measurements. So the interaction of magnetic field with superconductivity, as a result of, I can deliver a lecture about this. So, but I want to say that people did not believe in this story. It was very important that half a year later, Ryabinin and Shubnikov, so Shubnikov with his collaborator, confirmed the existence of Meissner effect in completely other way. They measured magnetization of the rod, superconducting rod in parallel magnetic field. So this fact became reality. And it was done independently. And after only 1 year, he bought liquefier from Meissner in 1933. And Meissner visited Kharkov. So Kharkov, in some sense, was a mecca. You will see other names those times for European physics. Okay, so then, so this was very important. But then we know that Shubnikov and Ryabinin studied superconductivity in metallic alloys, and they found some partial, so this is the type 1 superconductor, this is type 2, this is in accordance to Abrikosov, the second critical field and so on. But what's found Shubnikov, that here it was not complete Meissner effect. So it was not just jump from superconductor state to non, but something intermediate. And now we identified, we call this Shubnikov phase. Of course, people those times could not even imagine about vertices. It was completely merit of Abrikosov. But they realized this with impurities. Nevertheless, the fact that he found the Shubnikov phase is very important, crucial. So if he were alive, they could have Nobel Prize much before, together with Abrikosov. Experiment and theory. So in 1932, Landau followed the road of Shubnikov. From Leningrad, he moved to Kharkov. And this was very fruitful period. You see Kapitsa with it again. Here, you will see again that Landau, for instance, Laszlo Tisza, was Hungarian, who studied with Max Born in Germany, and then Max Born sent him to Landau. Landau was his advisor for PhD. And many, many other names. You will see how some of them will finish. Sorry? I do not know. I'm sorry, maybe this is wife of Shubnikov, because she was physicist, Trapeznikova. But I will study. So you see the first book of Landau, famous Landau course, mechanics. It was published in Kharkov in 1935. You see the full, complete set of books. And Landau, those times, Landau was always interested in dissemination of knowledges. And he's creating his school of physics. Here you see the charge, the caricature, Landau with the wings as a god, and here there are his pupils, because Landau was a very rigid guy, and here it is written Dao said. So Lan is so Dao told. So it was a voice of God, and he created very successful system of selection of scientists, Landau minimum. So Landau minimum was a system of 9 exams, maybe not 9 from the very beginning, but in my times it was 9 exams. So first math, second math, and then the volumes of the mechanics, field theory, quantum mechanics, relativistic quantum mechanics, statistical physics, electrodynamics of medias, the mechanics of medias, and someone who wanted to become theorist and student of Landau, he was obliged to pass this system of exams. And here you see the list written by Landau of 43 persons, where you will see first Compagnie's, then his co-author Lifshitz, Evgen Lifshitz, then Achiezer Pomeranchuk, and Tissa. Fifth person who passed through this machinery was Laszlo Tissa. This is important. Laszlo Tissa, who came by recommendation of Max Born to Kharkov. Very good. So, as I already told you, Landau worked in the scientific institute, and he was professor of Kharkiv University. In 1935, this became the period of Stalin terror. So start the this like McCartney, the struggle for witches, and Landau was kicked out fired from university because of his idealistic ideas of quantum mechanics. What is important that these were still times when people believed in freedom. So, as a protest, Shubnikov, Achiezer, Lifshitz, and Rozenkevich, they resigned from teaching in Kharkov University. In 2 years, they were arrested and accused that it was a collective, important that not individual, but collective anti-Soviet action. So, nevertheless, Landau continues to work, and he creates, I want to recall you why, because in 1923, together with Leo Dana, still Kamerlingh-Onnes studies the temperature dependence of specific heat capacity of liquid helium. They conclude that near the temperature where the maximum in density reach something happens to helium. So they found discontinuity. And they write about this. They call it lambda point. First time appears word lambda point. Then, in 1932, Kazum and colleagues conducted a series of experiments that revealed a jump-like change in the electronic heat capacity of tin and thallium near the transition. You see, again, they found the jump in heat capacity. Again, and in the same year, Paul Ehrenfest classified phase transitions based on the behavior of thermodynamic free energy. So he identified, it is a question of definitions, but he identified when I have started, how many minutes I have, because maybe I'm too slow.
Go ahead. I will stop you at some point.
Okay, okay. So he identified the type of transition with the derivative of the energy which breaks. So water, ice, first order transition because breaks entropy. Heat capacity for the transition from diamagnetic to ferromagnetic, superfluid. So it was clear necessity to explain this phenomena. And it was Landau who proposed his simple model, still not functional, function of thermodynamic potential of free energy in the form of the expansion of the other parameter. He introduces the notion of other parameter, which defines which distinguishes the symmetry of high symmetry phase from low symmetry phase. And this simple idea allows him to explain qualitatively what happens during second order transition. Very good. I will accelerate. 20 minutes. Very good. So arrived 1937, the black year of Stalin terror, and so which was KGB defeats Kharkov research. In 1937, 5 leading UFT employees were arrested and shot: Shubnikov, Rozenkevich, Gorsky, Fomin, and Weissenberg. 2 foreign nationals were arrested and later extradited to Gestapo. That was Huttermann, a member of the Communist Party of Germany, and Weisberg, member of Communist Party of Austria and Germany. In April 26, in Moscow, so Landau foresaw what is happening. So he, by invitation of Kapitsa, moved to Moscow to just created Institute of Physical Problems. And nevertheless, this did not save him. In April 28 of 1938, he was arrested. And he spent in prison 1 year. April 26 of 1939, I will tell you why I say you all this date, Kapitsa, who wrote the letter to Molotov asking release Landau, he visited the high rank officials of KGB. And they put at the desk 3 volumes of the case of Landau and told, read, he is a spy. Kapitsa told, no, I will not read. I did the discovery of the world level superfluidity, and I need the theorist who will explain it. The only such theorist in the world is Landau. So give me Landau by my guarantees. And Landau was released. And then in 1941, he wrote his 2 liquid model. 30 of May, we had in Lincei meeting devoted to cold gas, and first session was devoted to Lev Pitaevsky. And it was very nice. Pitaevsky was in this list, of course. He was pupil of Landau and a wonderful scientist. But Ketterle, the Nobel Prize, started his talk with the controversy between Landau school, and he mentioned the following. He told, look, Fritz London published in Nature 9 of April of 38, he published the idea about superfluidity, that idea that this is Bose condensation. 20 of May of 1938 in Nature appeared the article signed by Tissa, student of Landau, and Fritz London, with whom he worked in Paris, the idea of 2 liquid model. Why Landau did not refer? Why Landau did not make references? So this was the pretension of West School to, and it repeated in 2023. So I allowed myself in comments to present these dates, which I told you. So 9 of April, Landau was waiting to be arrested. 20 of May, he already was in prison. Then he was released. You may imagine, who was Tissa? Tissa in archives of KGB was a resident of Gestapo in Kharkov. It was absolutely crazy. Now there is a beautiful book devoted to Lev Shubnikov where I learned a lot of these things. Then, when Landau was released, he could not make reference on spy Tissa and Fritz London, so he could not, because he was released with the compito, I don't know how to say in English, with the task to create theory of superfluidity. Moreover, Diba Khmelnytsky told me that even at the end of 40s, Migdal approached Landau and told, I have the idea about helium, and Landau, don't touch helium, this is my topic. So still he had this fear. Okay, so I will proceed more fast, but enough history. So you see that this is extract from the protocol of the decision of People Commissar of Internal Affairs to shoot Shubnikov. So the person who could get Nobel Prize was just killed. Now I will skip 15 years. War, I do not know nothing about this because Kharkov was bombarded. But I will pass to another wonderful school of Kharkiv Center. It was established by Ilya Lifshitz. You know, maybe you mix two Lifshitz. They were brothers, Evgen Lifshitz and Ilya Lifshitz. Evgen Lifshitz was the devoted student of Landau. He was his Santo Pancho, thanks to whom exists the course. While Ilya Lifshitz politely stressed that he never was student of Landau. Ilya Lifshitz was quite different person in comparison with his brother. Brother was always dressed perfectly, rigid, without smile. Ilya was very smiley, was always open to his students, and he created beautiful school of theoretical physics. So here you see Ilya Lifshitz and what the group of his students, Musik Kaganov, with whom I had pleasure to work, and we have review in 1994 devoted to electronical topological transitions. Musik was wonderful professor of Moscow State University later. This Kanner, Kasevich, Asbel, Pishansky, here present colleagues from Kharkov, and they will get and Viktor Galovsky. So these names for them are important. And they created they did fundamental discoveries in physics of metal. So it was a period of construction of quantum theory of metals. And so they studied galvanomagnetic and high frequency phenomena in metals, different types of resonance, size effects, the rise of fermiology, electronic topological transition. I will not go, I do not have time to this topic I could deliver good because these are two chapters of the fundamentals of metal theory of Abrikosov, which I delivered many years. So it is for me very close to my soul. This is indeed beautiful theoretical physics, which was done in the 50s by these people. In 1960, Ilya Lifshitz proposed a theory of electronic topological transitions. So he found how topology affects on electronic properties. So in classification of Ehrenfest, this is not the second order phase transition, not the third, because there is a break of the third derivative of free energy, but as a 1 over square root closeness to this transition. In 60s, it was not so appreciated, because he spoke about thermodynamic properties. But at the early 80s, it was found in Atomic Energy Institute that in transport, these topological transitions give the giant anomalies in thermoelectric power, etc. And today, still, we wrote with Musik Kaganov and Slava Blanter, who was my student, and Andrey Pantsulayev, who unfortunately died early, who was my student. We wrote this report, which is still cited, and I hope is useful to people, because now people study much more sophisticated systems, like cascade Lifshitz transitions in heavy fermion systems. So still, this topic, so Lifshitz started this activity, which already 60 years is fruitful. Okay, so I will go ahead. And now, Valery Pokrovsky, whom all of you know by his book and fluctuation theory of phase transitions. I would say that Kenneth Wilson acknowledged Potoshinsky and Pokrovsky, and Leo Kadanov for important contribution to the theory of critical phenomena. I would say that here should be added Iona Lazinio and Carlo Di Castro for their paper of 1969, but they did renormalization of green function, and Wilson did renormalization of action. So all of before him. So his merit was this, but the discussion, the people were very close to explanation of the theory of phase transitions in microscopic way, not like Landau. And so Valery Pokrovsky was apprentice of Ilya Lifshitz. 60s and 80s, fundamental studies of superconductivity. Janssen, Svistunov, Dmitrienko discovered the non-stationary Josephson effect. Concretely, first experimental observation of electromagnetic radiation, Josephson generation from Josephson tunnel junction, and they detected power from blah, blah, blah. 1970, Igor Kulik discovered the first steps of mesoscopic physics. Igor Kulik predicts the existence of persistent currents in normal clean nanorings. So in 77, Kulik with Emelianchuk discovers that properties of microbridge in ballistic regime, always clean, they found the oscillations of Josephson current, superconducting microbridge in the pure limit, they found not sine phi, but sine phi over 2. And you see that close to Tc, when delta is small, you pass to sine to cosine, gives you sine or phi. So this was a beautiful discovery of half phase Josephson effect. Then Robert Schechter, together with Kulik, he studied kinetic phenomena and discreteness effect in granular media. So first step in granular superconductivity, granular media, they add to nanogranulars, they add Coulomb energy and tunneling, and competition between these two effects, which now are in the textbooks. Then Kulik with Emelianchuk Schechter study electrical conductivity again of microbes. So all this activity was in Kharkov. Lenya Glazman, who now is famous professor of Yale University, he was born and studied in the first steps did in Kharkov, and to him belongs together with Robert Schechter the Coulomb blockade of the conductance in the laterally confined heterostructures. Then Leonid Pastor, I had the pleasure to have a lunch with him 2 weeks ago, and he is very finely mathematical physicist. So he was one of the creators of the theory of random matrices. And he has a lot of results, but one of them, they rigorously demonstrated the existence of Anderson transition in one-dimensional systems. Okay, I pass to Kyiv Research Center. Do you have another 10 minutes or 5? How much?
Let me check.
10 minutes. Okay, I will finish. So, Kyiv Research Center, it consists today more or less, this is Academy of Science, this is Institute of Semiconductors, this is Institute of Metal Physics, this is Institute of Physics, and Institute Bogolyubov Institute of Theoretical Physics. The story started in Institute of Physics from Loshkarev, who discovered p-n junction. Don't ask me to compare with, I know that Nobel Prize for Semiconductors got Barty. I'm not so expert in semiconductors to explain who was what is the merit, but it is considered that he studying the thermoelectric power found existence of p-n junction. Next was Pekar polaron. This we know very well what means polaron, so you have the excess electrons or holes in the good polarized crystal, and due to charge dipole interactions, the charged particle create for this the hole. So this is a Pekar polaron. Bogolyubov. So the idea about superfluidity, explanation of superfluidity as a Bose condensation was proposed by Fritz London 3 months later after the discovery by Kapitsa and J. Cullen. But Landau did not do superfluidity in the Bose explanation of superfluidity. And in 1946, Bogolyubov published his famous paper devoted to the properties of interacting Bose gas. And he demonstrates that even in the case of interaction exists phenomenon of Bose condensation. Davidov proposed a theory of exciton of molecular excitons. So again, I will not enter in details, but the idea that you have excited states in molecules on atom, and they can transfer energy in crystal if there is a corresponding energy spectrum of the closed molecule. So, his prediction was checked and demonstrated by Antonina Prihodko in Institute of Physics. It is called, so it is necessary to speak about some symmetries and several molecules. So finally, you have this Davidov splitting. Talpiga, in 1950, he predicted bound states of photons and optical phonons. So photons in restricted space in crystal, they can form the special quasi-particles which are binding between photons and photons. And it is a polariton of Talpiga. Rashba. Now everyone knows about Rashba effects in orbit coupling and where spin coupling to electric field comes from. This is a piece of transparency which Emanuel Rashba delivered in Santa Barbara. Many years he worked in Kiev. And then he moved to Institute of Landau. Mikhail Krivoglas, he was the director of the department of defects in metals in the Institute of Metal Physics. By the way, two of these persons were my contra-referee on my PhD. One was Kulik, another was Krivoglas. So, and Kaganov was in the habilitatus. So many of these people I knew personally. I had this privilege. Okay, so he developed the theory of diffraction of X-rays, electrons, and neutrons in real crystals. He wrote the monograph, which is the handbook in this field for people. Okay, I'm finishing. So Davidov, the birth of quantum biology. So he introduced the notion of molecular solitons to explain the transport of energy in proteins and the physiology of muscle contractions. He wrote this equation, nonlinear Schrödinger equation, and analyzed it. More recent times, Gusenin, Miransky, and Shovkovy published a series of work discovering magnetic catalysis. Then Gusenin and Sharapov, my co-authors, and with whom we had grants in last 10 years together, devoted to graphene, they predicted the quantum Hall effect for Dirac equation in very particular form, and the experiment shows exactly this quantization. Quantum Hall effect became the main among the three proofs that graphene is described by the Dirac equation. Now this paper has 2,000 citations or something like this. Lara has probably even papers together with Sergei. You work together in Switzerland, I remember.
You know the story of this paper report.
Not.
When you worked the first time, it was immediately refused by the editor because the paper was the following. This is the equation to describe the all affecting the thing. So there was no introduction, only one line. The reason in the paper, I didn't know what I said. Okay, why don't you try to write an introduction to explain normally to people why this is so important? So they recorded.
He changed.
They submitted the paper and then.
Yeah, because after Lausanne, he was my postdoc in EASY in Torino, and then we did with him maybe 15 papers. Yes. Okay. Then last what I want to say is the spintronics of anti-device systems. Okay, I will not enter in details because I do not know. I just can, impossible to know everything. Okay, now I wanted to show you the nice pictures of our recent past. These are years 2010, 2019, where we had a strong collaboration with Institute of Semiconductors, with Bogolyubov Institute, ICTP, Sandra is here, organized in 2015, beautiful international conference in Kiev. So we had very good and fruitful relations with Ukrainian science. This person was a vice director of Institute of Semiconductors, and I had a strong discussion with him because I delivered the lecture in their institute, and we had strong discussion with him in 2019. Then I will pass to Ukrainian science after February 24. So on February 24, Russia unleashed the military aggression against Ukraine. As a result of military strikes with missiles and bombs on peaceful objects, the scientific structure of the National Academy of Science of Ukraine continued to collapse. Due to the military aggression of the Russian Federation against Ukraine, about 1,500 of employees of scientific institutions of the National Academy left Ukraine. More than 370 scientists are in Germany, 270 in Poland, about 100 in France, 68 in the USA, and 66 in the Czech Republic. This data I received from the president of Academy of Science, so they're not today, they are varying, of course. Here, nothing to comment. You see Kharkov University in 21 and 22, in 41 and 42. Find the difference. And this is a martyrology of Ukrainian science. You see this vice director of Institute of what concerns me personally, because this data we found with Yura, we found from academic sites and from Academy of Science. But Vasily Kladko, with whom I had scientific dispute, the March of 2022, they have small dacha in Bucha, and he went to take his wife and daughter. All were shot. So one person I knew personally. But I don't want to stop at this, to close my talk with this memorial and very sad slide. So yesterday I spoke with Sandra, and Sandra provided me by this positive, so it is necessary to look future. And thinking about future, the colleagues from United States, from Europe, are thinking how to create some replica of ICTP, if you want, a place where people meet, where it is possible to for young people to meet good advisors. So the vision of this Center for Advanced Studies is physically placed in Kiev. The local activities are led by 10 senior and 10 junior staff members who have demonstrated their international leadership and visibility in their fields. The center will support 10 postdocs with prestigious names of Bogolyubov, Landau, Lifshitz, Pomeranchuk, Sikorsky, Krylov. Annual open competition. And then center will run 6 annual 2-month-long topic programs. So this is, you see, in some sense, copy of the prominent institute of the International Center for Theoretical Physics in Trieste, which demonstrated in almost 60 years of its existence its extreme efficiency. So I want to finish with this slide and believe that it will be realized and we all will be able to participate in it. And the last slide, it is acknowledgement of people with whom I had I consulted, who helped me to collect the material to classify it, and that's all. Thank you very much.
Thank you, Andrey, because the talk was great, but I've left no words after your emotional, So, thank you.
Thank all of you for this applause, which I consider as a support and appreciation of science in Ukraine. Per essere venuto.